Welcome to Retro Depot. My name is Doug. Today we're going to be taking a look at the RD10 docking station for the MX-10 computer that I designed. It's going to be a fairly short video because there's not a whole lot to show as far as the functionality of it's concerned. But I did want to document this for anybody that's looking at trying to build something like this or needs a docking station for an MX-10. This is going to be a pretty easy and fairly cheap solution for you. So sit back and get ready for the video. So today we're going to be taking a look at the RD10. The RD10 is a expansion or a docking station, if you will. It's something I designed for the MX-10 computer, which you can see here. It's a pretty small little MSX computer, but it's actually kind of a cool little machine, to be frank with you. It's one of those machines that it can be had fairly cheap. Whenever I bought this one several years ago, I think I got it for about $70 to $80. Now they're a little bit more expensive. You can get them for in the area of, let's say, $100 to $200 at current pricing in 2021. They are going up in price just simply because everything is going up in price, and if you guys didn't know, the value of the dollar is kind of going downhill. We don't manufacture a lot of things here, and with our economy in the last couple of years, it's really tanked to an extent. I think inflation's caused the buying value to go down about 5.5%, 5.9%, somewhere in there. So they are getting more expensive for us here in the United States as far as purchasing these things, and I'm sure that they're getting more expensive throughout the world as well. But that said, it's a very attractive small MSX1 compatible. It does have a kind of a rubber chiclet style keyboard, and it does have a built-in game pad right there on the keyboard. So it does have that going for it. You don't necessarily have to have a joystick in order to be able to play games with this, but it is, to say the very least, fairly anemic. And what I mean by that, it only has 16 kilobytes of memory internal for the system, and that's not a whole lot to play games. So you may end up needing to have some type of expansion that allows you to have additional memory. The SD512, that's one option, and it's an option that I use quite a bit. I've thought about trying to place some memory on this adapter as well, but in order to do that, I need to break out slot 3 into sub-slots, and I just don't really care to do that at the moment. I'd rather just have this set up so that you can add in additional cartridges, and most people that have MSX computers are going to have some type of RAM cartridge anyways, so that's not really going to be needed for most people, because if you have one of these, you probably got a couple MSX computers, and if you have one of these, you can plug in a RAM cartridge. You're not really going to have that need. But we're going to get right into this. I'm going to try not to take up an hour of your time with this video. I know the last one, especially considering it was me building this, it took a lot of time, and I tend to be fairly long-winded anyway, so we're just going to get right to it. So to use this, you have to first make sure that you've taken the back cover off. The back cover, it just slides right out. This is what it looks like. It's just a little piece of plastic that comes in and out. You need to take that off, and then the next thing that you need to do is actually take it and plug it into that slot. Now, I've got some standoffs on this PCB so that it will actually hold itself up off the table at approximately the right height, and we're actually going to put this in here at sort of an angle so we can see exactly what I'm doing here. As far as the machine set up, we are going to have a power supply connected to this is an AT power supply, by the way, but it is connected to the back of the floppy drive. I've got a power switch that I've installed on this. This is what I use for testing PCs and other devices. We've got our floppy card here. We're going to go ahead and stick that in slot 2, and we are going to take our SD512 and we are going to stick that in slot 3. Now, as far as the audio and power, I've got that hooked up through just some, RCA cables to the back of the TV here. And I've got a power cable here. This is just 12 volt DC, and it is center positive. And we are just going to plug this right in. Now, when we've plugged this in, you can see it starts to boot up. It is, going through the process of booting off of the SD512. It does have floppy support here, and that's a great thing because it's got two separate slots. It reads these as two different types of disk drives here. But once this gets done booting up, you can see we're into Next Work Basic. This is actually in, I think it's modified MSX-DOS 1 mode. So it doesn't have as many features as what you would have with, MSX-DOS 2, but it's still fairly practical. So we can list out the directory here, and gives us everything. Now we are in 40 column mode because it doesn't have 80 column mode on the MSX1. If we type A:, it should boot from the floppy drive. Oh, I guess it'd probably help if I had the floppy drive available here. Forgot to actually turn the power on, but as you can tell, it did seek, and it did give us a listing. It does have one program. It's test.bas. That is a basic program. So if we type basic, I think we can actually launch it from MSX-DOS. Yep, see, it automatically runs the program there. And if we actually list this out, you can see it's a simple for loop. It's a 10 for I equals 1 to 10, 20 print I, 30 next I, and then that's just the end of the program. So if we type in files, it does show that it's working, so it lists it there. But like I said, how do you know that that's not just on the SD512? Well, we're going to unplug this, and we are going to remove the SD512 from the machine. So I'm going to stick this over here, and we are going to plug this back in. And when we plug it back in, it's going to seek from the floppy. Takes just a second, and it's rebooting because this one probably has a boot sector on it. So let's unplug this and try one more time. So now it's asking us to enter the date. And I've actually modified the ROM that I have on this floppy controller here. The reason why I did it was because the original one was in Japanese, and I don't read kanji. I'd love to be able to read kanji because there's a fantastic amount of games out there that are in Japanese kanji, but unfortunately I'm from southeastern Oklahoma. I barely speak English. So we're just going to plug in the year here. So 2-1, and then it's going to be dash 10, and today is actually the 23rd. We're shooting this video about 2 weeks early, but we can plug in the date there. And then if we type files, I guess we got to put the disk in. So let's go back up. So now it's going to tell us that it does have test.bas. We can load test.bas. Takes just a second. It does load it up. We can list out that program. And now it shows this program, and we can just simply hit, I believe, F5 run. So yeah, there we go. Now if we unplug this, we know that the floppy drive is working. We can go ahead and eject that floppy drive out for just a second. Plug in the SD512, boot the machine back up. going to go ahead and boot from the SD512. And now we're back. So next we can type SR because I have SOFA run as a executable here. It actually needs, let's see what it's doing. Yeah, so let's go ahead and unplug this. Let's plug the SD512 into slot 1. I think this should make it show up as A. I hope it does. Yep. So if we type SR, it's going to launch this. And we'll have to find some games that we can play with this because not all games are going to work because this is a MSX1. So I wonder what will work here. Give me just a second. We'll find something. I'm not sure if this is going to work or not. It may need a MSX2 video chip. I don't have these broken down by MSX, so. Oh, there we go. Antarctic Adventure. So we're just going to play a quick little game here. Oh. There we go. Something else that I probably should think about adding to this would be a reset button. The biggest reason behind that is because, unfortunately, with these MSX cartridges, there's no way to back out unless you actually have a reset button or you want to power cycle the machine. So, but yeah, that's the operation of the RD10. I'm actually quite happy with the way it worked out. Yeah, it actually worked out to be a pretty good little expander for this so far. Now, what we do need to do is talk about how this can be improved. And to be short and simple and to the point, there's a little bit of room for improvement. The first thing, the transceiver, the Databus Transceiver, I did end up removing that. At first I used jumpers in order to be able to test it because I was having some type of timing issue with the Databus not able to either read or write to that transceiver quick enough. I think it was more of an issue with reading because it tended to crash whenever it was trying to read from it. However, once I replaced it with jumpers, I didn't really have any problems after that. The timing for the control logic for the adapter works fine, but it still poses a problem for Databus Contention. And what that is, it's where the any type of bidirectional signal tries to take control of the bus at the same time, and the data gets corrupted, and it just causes all kinds of problems. The machine wouldn't boot whenever I did have the data transceiver in there because it was having that issue. So that said, I decided to go ahead and put in some resistors for protection against that. Now, it's a very cheap way of doing it, but it's also pretty effective. It will allow the CPU to assert control no matter who's trying to talk on the bus. So that's really nice in that it protects the computer itself from burning out. If something on the RD10 burns out, well, that can be replaced. We don't need to worry about that too much because at the end of the day, parts can be replaced. The computer itself is what needs to be protected. So I think those resistors were a pretty decent compromise. The next thing that needs to be added, and it really is to serve to get rid of the power supply itself, or some secondary alternate power supply that you may have. We need to actually add in a header for connection of the floppy drive. Now this is pretty simple because a floppy drive needs 3 voltage levels. It needs a reference voltage, which is commonly known as ground. It needs 5 volt to be able to run the internals, and sometimes they need 12 volt. It depends on the model, but sometimes they do, sometimes they don't. So by adding in a 4-pin header here, and the fact that we already have those 3 voltage levels on the device itself, because we are using 12 volt power, and then we are using a regulator to bring that down to 5 volt. We already have ground because ground is used with everything. It's a reference voltage. So we have all the levels needed. We just need to add in that 4-pin header. That way we can attach a cable from the adapter to the floppy drive. The next thing that needs to be added would be a power switch. Obviously a power switch so that we don't have to unplug and plug back in the power cable every single time that we need to cycle the machine. And also, like I mentioned before, a reset switch would be nice as well. Now, with all those things said, there's a couple other things that I've thought about adding to the board itself. I thought about taking slot 3 and mapping that out into sub-slots and essentially breaking off slot 3, which is the 4th slot of slot 3, the 4th sub-slot of slot 3, and using that to put in a floppy adapter, its memory, or a OPLL like the FM pack has, along with a ROM and a memory for that. The purpose of doing that is so that we have more than 16 kilobytes in the machine itself. But like I said, I'm not really too worried about it because chances are you're probably going to have some type of RAM cartridge there. So really the only advantage would be to put in either a floppy adapter or a OPLL like the FM pack. But in doing that, we actually lose some of the capability of slot 3. And what I mean by that is with slot 3, anytime that you add in, for example, an SD512 or any RAM cartridge, a lot of times they are mapped to all of those sub-slots in order to get the amount of memory that you need in order to have that cartridge or just some of the features of it. So you lose a certain amount of functionality of slot 3. So I've thought about it and then I kind of backed out because I don't think it's the best thing to do, although it would be nice. I think that a better solution would possibly be to map a slot 1, because we can put it in slot 1. There's nothing that prohibits us from doing that. To my knowledge, on this machine, slot 1 is mapped out in a manner that it's got about 116K that's completely open. And if we put the ROM cartridge in that and we map it out, I think that we might be able to make this machine capable of reading from slot 1. But the problem with doing that is this. There's no way to know for sure, because since they used a CPLD inside of this instead of an actual MSX engine, you're in this position where even though there's now a schematic available, I've posted it on my website with a blog on this, there's no way of actually knowing what those signals are intended to do, where this is mapped, whether it's slot 1, slot 2, slot 3, slot 4. We just don't know. So I think that there's some code out there that you can run that tells you exactly where the map of everything is. However, I haven't seen any of it out there. I'm pretty sure that I've heard people talk about running certain commands or certain basic programs that will tell you what is in each slot, sub-slot, and windows within those slots, or pages, if you will, because everything's set up in 16K pages, slots, and sub-slots. So that said, once I get a little bit more knowledge on how that's done, I may go ahead and add that in, but I would probably add it in a sub-slot for slot 1. That way we're not interfering with slot 3. I really would like to keep slot 3 open for expandability purposes. But let me know what you think. If you have any questions about today's video, about the adapter itself, about my design process that I went through whenever I was building this, feel free to reach out to me. You can ask in the comments below. You can actually reach out to me on my website. I have a contact us form that will send me an email, and if you put your own email in there, I'll be able to respond to you. I use that method to keep myself from getting just absolutely annihilated by the spam bots that are out there. If you don't have a website, you probably aren't familiar with this, but they are horrible. I get probably 400 spam bots a day that, thankfully, because I handle it that way, it knocks them out. But yeah, reach out to me. Also, if you have any of your own projects that are, with the MSX or home computers, anything like that, you want me to take a look at it, tell you what I think, maybe even shoot a video, be happy to do that. You'll just have to make sure that you get me whatever I need to do it. Of course, you can always reach me via my website. That's probably the easiest way. I'm also on the Discord channel. You can reach out to me by Twitter as well. I've recently started up a Twitter account. I don't post a whole lot on there, but it's at least there for interaction. So, like I said, that's about it. But I would like to thank you for taking the time to watch the video today. Like I said, we're trying to make this one short because the last one, I think, was an hour and 20 minutes. So, take that for what it is. But if you like today's video, I would ask you to hit the like button, or if you dislike it, hit the dislike button. That helps my metrics as well. It tells me what people dislike so that I can change my videos to suit the audience. And as always, if you do like the videos as a whole, I do ask that you subscribe. It really does help me get out there into the other spaces of YouTube so that people that like things like you see my stuff. So, alright guys, again, thank you for watching the video, and we'll see you next time.